We present secondary mathematics for Form 1. This is Program 1 of Term 2. Our strand today is volume and capacity. Our substrand is volume of cubes, cuboids, and cylinders. During the program, you will be required to take short notes and answer questions. Welcome to the program.
Hello Form 1 learners. I'm Teacher Maura. In today's class, we are going to discuss volume of cubes, cuboids, and cylinders. With me are 3 Form 1 learners. Let them introduce themselves.
Hello viewers, my name is Manu.
Hello viewers, my name is Mutua. Hello viewers, my name is Lulu.
In our previous lesson, we learned about area of regular shapes. So today, we are going to learn about the volume of cubes, cuboids, and cylinders. Learn, what do you understand by the term volume? Yes, one.
Volume is the total amount of space occupied by a solid object.
Correct one. Volume is the amount of space occupied by a solid object. The SI unit of volume is meters cubed, denoted by small m cubed. We also have other units of volume, other units, which include, we have millimeters cubed, decimeters cubed, decameters cubed, etc. Can you give examples of regular solid? Yes, Mutua.
Examples of regular solids are cubes and cuboids.
Very correct, Mutua. We have cubes, cuboids. Yes, one.
We also have pyramids, cones, and cylinders.
Pyramids, cones, and cylinders. Excellent one. All those mentioned are examples of regular shapes. Now let's focus on volume of cubes, cuboids, and cylinders. Let's start with the volume of a cube. A cube is a regular shaped object whose all sides are equal. As you can see in our chart, it's a cube. All sides are equal. Set about f for length. Its formula is given by length multiplied by length divided by length to give you length cube. So let's visualize this with an example. So an example. Find the formula, find the volume of a cube whose length is 5 centimeters. First, from our formula, volume is equal to length cubed. And where length we are given as 5 centimeters. So our volume will be equal to length times length times length. Replacing our given length is 5 centimeters. We have 5 centimeters multiplied by 5 centimeters multiplied by 5 centimeters. Where we get 125 centimeters. Find the volume cubic. Try this out. Find the volume of a cube is 20 centimeters. Whose length, find the volume is 20 centimeters. Find the volume of a cube whose length is 20 centimeters. Yes, Deori?
The volume of a cube is equal to length cube. Given the length as 20 centimeters, therefore the volume will be equal to 20 centimeters multiplied by 20 centimeters multiplied by 20 centimeters, which will be equal to 8,000 centimeters.
That's correct, Deori. Now let's shift our focus to volume of cuboid. Let's focus on the volume of cuboids. In our chart here, we have a cuboid. Was just a cross-section area of a rectangle, which is length times width. Then we have a height. So from the chart, the volume is cross-section area times height. Our cross-section area is a rectangle whose has length times width times height. Let's visualize this with an example. When the volume of a cuboid whose length width and height are 9 centimeters, 8 centimeters, and 7 centimeters respectively. Solution. From our definition, the volume of a cuboid is equals to cross-section area inside, where I have length times width times height. Replacing our variables, where length we have 9 centimeters, width we have 8 centimeters, and our height here is 7 centimeters. We get the calculation we get 504 centimeters cube. So now, try this out. Find the volume of a cuboid whose cross-section area is 120 centimeters square and its height is 10 centimeters. Try that out. When the volume of a cuboid whose cross-section area is 120 centimeters square and its height is 10 centimeters. Yes, Mutua.
So from the formula, which is cross-sectional area times height, we can replace our cross-sectional area to be 120 times 10, which is the height. Then we get 1200 centimeters cubed.
1200 centimeters cubed. That's correct, Mutua. Now let's try this another example. When the volume of a cake whose inside is 20 centimeters long, 50 centimeters long, 15 centimeters wide and 40 centimeters deep. Let's try this out.
From the formula, the volume of a cuboid is given by the length times width times height. The length in our case is 20 centimeters, the width is 15 centimeters, and the height is 40 centimeters. The volume of the cuboid is given by 20 times 15 times 40, which is equal to 12,000 centimeters cubed.
Awesome one. Now let's look at the last problem. We use a cylinder. From our chart here, the volume of a cylinder is given by pi r squared height. Pi r squared height is derived from we said volume is equal to cross-section area multiplied by height. In our case here, our cross-section area, which is visible to us, is the circle. The area of a circle is pi r squared. Here denoted by pi r squared. Replacing it with cross-section area pi r squared multiplied by the height, which gives us pi r squared height, which is our volume of our cylinder. Now let's do an example to visualize the formula. Find the volume of a cylinder. We find the volume of a cylinder. Volume of a cylinder whose radius 14 centimeters and a height of 27 centimeters and a height solution part. For you to be able to solve this problem, first you need to draw a sketch. You have a cylinder whose radius, our radius here is given as 14 centimeters and the height is 27 centimeters. So from the formula, volume is equal to pi r squared height, where the pi is always given by 22/7. The formula for volume is equal to pi r squared height. Replacing the variable, half pi which is 22/7. R squared is 40, that means 40 multiplied by 40, and our height we have as 7. So we have volume is equal to 22/7 and 14 and 14 and 7. By 7 here we 1, 2. Of 22 multiplied by 2 multiplied by 14 multiplied by 27, we get 16,600 centimeters, because it's volume and you know the size of volume must have a cubic equals cubic. Now learners, try this out. Find the volume. Find the volume. Find the volume of a cylinder. Cylinder whose diameter is 28 centimeters and has a height of 10 centimeters. Find the volume of a cylinder whose diameter is 28 centimeters and has a height of 10 centimeters. Yes, theory.
Given the height as 10 centimeters, the diameter as 28 centimeters, we can find the volume of the cylinder by first dividing the length of the diameter by 2 to obtain the radius as 14 centimeters. Now, substituting to the formula, volume is equal to pi r squared multiplied by the height. Volume equals to pi r squared multiplied by height. Pi is equals to 22/7 multiplied by 14 times 14 times 10 centimeters. This will be equal to 6,160 centimeters.
That's correct theory. When given a diameter, first divide by 2 in order to obtain radius. That's good. Now learners, in some cases, the question on cylinders may not be brought directly. They may be in some cases ask you to find the height, in some cases find the radius. Let's look at case 1. Case 1, where you are asked to find the radius. So for example, find the radius of a cylindrical tank whose volume is 1540 centimeters cubed and has a height of 10 centimeters. Find the radius of a cylindrical tank whose volume is 1540 centimeters cubed and has a height of 10 centimeters. You are asked to find the radius. So the solution will be, we are given our volume is given as 1540 centimeters cubed, the height of 10 centimeters, so we are supposed to find the radius. So from our formula, volume is equal to pi r squared h. From our formula, volume is equal to pi r squared multiplied by height. So replacing the variables that we have, it will be equal to 1540 equal to pi, which is 22/7, multiplied by r squared, we don't have the value of r, multiplied by height, which is 10. For you to remain with r squared on one side, the other values you should bring them on this side. So it will be equal to 22/7 times 10, it will be equal to 220/7, r squared is equal to 1540. To remain with r squared on one side, you should multiply by the reciprocal. So here you should multiply by 7 over 220 on both sides by 7 over 220. So on this side, r squared remains. This side, by calculation, you will get 49. Since we want the value of r squared, in order to get the value of r, we should find the square root. So the square root of r squared, square root of 49. So here you get square root of 49 is 7, and the square root of r squared will be r. So your answer will be r is equal to 7. Our units that we used were centimeters, so it will be centimeters. With that marks the end of our lesson today. Now let's summarize what we have learned. What have you understood today? Yes, Mutwa?
Yeah, so today I have understood that the volume of a solid is the amount of space occupied by the solid.
Yeah, that's correct. The volume is the amount of space occupied by a solid object. Yes, Mwangi.
Today I have understood that the volume of a solid object is given by the cross-sectional area multiplied by the height.
That's correct. We said that the volume of any closed object is given by its cross-section area, which is visible to us, multiplied by its height. Yes, Deuri.
Yes. Today I've learned that the the volume of a cylinder is given by pi r squared multiplied by height.
That's correct. Volume of a cylinder from a chart is equal to pi r squared times height. Yes, Mutua.
I also learned that the SI unit of volume is meter cube.
Very correct. We said that the SI unit of length of volume is given by meters cubed. From maybe length meters times meter, you get meters cubed. And that marks the end of our lesson today. Between now and our next class, we should revise on the volume of fractums and pyramids. For now, that's a bye-bye.
You have been watching program number 1 of term 2 in the secondary mathematics for form 1. Our strand today was volume and capacity. Our substrand was volume of cubes, cuboids and cylinders. The program was written by Victor Mwangi, Mary Mutua, Anne Theory, Francis Mwaura and Brian Kerich. It was edited and produced by Brian Kerich. Your TV teacher was Francis Mwaura and TV pupils were Anne Theory, Victor Mwangi and Mary Mutua. The technical operator was Brian Kerich. This program was produced in conjunction with the Department of Educational Communication Technology, Kenyatta University. Thank you for watching the program. Till next time, it's a goodbye.